In today's lecture, we will learn the main concepts of rectangular hyperbola, and today is the last lecture of hyperbola. So that means we will try to finish as much as possible from problems point of view also. We will complete the entire theory and also we will try to solve some problems on rectangular hyperbola. So can we start? In the last lecture, we have learned the standard equation and also we have learned how to derive these characteristics. Now you are not supposed to by heart these, you are supposed to understand how we derive them, because that is the skill that you are developing and it will help you in solving questions in exams also. Okay. So now here is the notation. So xy minus c square is treated as S, this is our S. So S equal to 0 will give us curve. Now when we write S1, if you note, here we cannot just write x1 y1, we have to write it as xy1 plus yx1 divided by 2, because here partial substitution means if the degree is 2 and if there is only one term x square, we can write it as xx1, if it is y square we can write it as yy1, if it is x we can write it as x plus x1 by 2, if it is y we can write it as y plus y1 by 2, but xy has always an issue. So what is the issue here? We have to do it like keep x away and substitute for y, and again keep y away and substitute for x and divide that with 2. Okay. So this way we can write S1. S1 equal to 0 will give us a line, we do not know what that line is, we will see that. S12 is an expression, it is a number, S11 is an expression, it is a number. Okay. So now how do we understand location of a point with respect to a curve? Suppose if I take this curve as y equal to c square by x, then if I am let us say going above the curve, that means if I am going in upward direction, for any point here y1 must be greater than c square by x1. Okay. So this will give us x1 y1 greater than c square, which means S11 is positive here. Similarly, if we go below this curve, S11 must be negative. So using this idea, we can say that for all interior points S11 is greater than 0. That means for these interior points also S11 must be greater than 0, and for all these points S11 must be less than 0. Okay. Now if the point is on, of course S11 will be 0. This is the idea. Even if you forget these rules, if you remember the idea of how we go above the curve and below the curve, then you can solve it easily. Okay. So remember the idea and after that you can do it on your own. Okay. Next. So this is what we have just derived. Okay. Now when it comes to tangents, these are all the concepts of tangents. Now which point to start with? In tangents, we always start with tangent at a point. So if the point is given to you as let us say x1 comma y1, how do you get the equation of tangent? By writing S1 equal to 0. So this has been the case with every curve, so we can take that as the standard form. Now what about the parametric form? In this S1 equal to 0, if we substitute the parametric coordinates of the point for x1 and y1, we will get the equation of tangent in parametric form. For example, if I take the curve xy equal to c square, so S1 equal to 0 is going to give us xy1 plus yx1 divided by 2 minus c square equal to 0. Now here in place of x1 I will put ct, in place of y1 I will put c by t. So what do I get? X into c by t plus y into ct equal to 2c square, and here one c can be cancelled, and if we simplify this we are going to get x plus yt square equal to 2ct. Now here there is some interesting idea that if we get the slope, it is minus 1 by t square, and we know that t square is a positive quantity. So here the slope of tangents is always negative. So, for this curve which is xy equal to c square, all tangents will have negative slope. For example, if we just check the curve, if we draw the diagram and observe it, all tangents will be inclined in this direction only. So, all of them will have negative slopes. Also, if you check for the normals, all normals of this curve will have positive slope. Okay. So, this is the parametric form of tangent. We can just write it as x plus yt square equal to 2ct. Now, you do not have to by heart all of them, you can just remember one or two, and based on that you can derive the remaining also. Okay. So, suppose after this, what is our next step? To understand this slope form and condition for tangency. So, these two can be done at the same time. Suppose let us say if I want to convert this equation of parametric form into slope form, how do we do that? We take this value to be equal to m. So, that means we are going to get t square equal to minus 1 by m and t will be equal to 1 by root of minus m. Now, here minus m is a positive quantity because m is a negative quantity. So, here if this value is substituted directly, we can get the equation of the tangent in slope form. So, how do we do that? So, here when we substitute, we get x plus y into minus 1 by m is equal to 2c into 1 by root of m. Now, when I multiply with m here and simplify, so I am going to get y equal to mx. So, we have to take y to the other side and this to this side. So, it becomes minus 2c, and also we are multiplying with m. So, it becomes root of minus m. Okay. So, let me just check the sign here. So, it becomes minus, so it becomes plus here. Okay. So, this becomes the slope form of the tangent. Okay. So, that means we can say that y equal to mx plus 2c into root of minus m is the tangent. So, what is the condition for tangency? If I take the line as y equal to mx plus d, then this d should be equal to 2c into root of minus m. So, that should be the condition, or we can just take d square is equal to 4c square into minus m, okay, but that is fine. So, here we have derived the 4 points here. Now, what about the tangents through any point? For this, algorithm still remains same. If you want the combined equations, it is SS11 equal to S1 square, and if you want separate tangents, you know the algorithm, put the point in the slope form and get the values of m and proceed. So, this is our next step. After we get the slope form, we take help of slope form to do this. And next concept is the director circle. We have already discussed the director circle when we are discussing the director circle of hyperbola. For rectangular hyperbola, director circle is a point which is the center. Okay. So, basically here the director circle is going to be x square plus y square equal to 0, which is the point which is the center only. Okay. Come on, make a note of this. Okay, next. So, these are all the concepts of tangents. Now, let us move on to the normals. Now, which one do we start with? We always start with normal at a point. Now, we already have the tangent. What is the equation of tangent? X plus yt square is equal to 2ct. Now, what is the pattern to calculate normal? Of course, we know that. Okay, so, this is the parametric form. Even if we go for the other form, which is xy1 plus yx1 equal to 2c square, here also it is going to be the same idea. What do? We change the coefficients. So, it becomes xx1 yy1, and we reverse the sign also. And what about RHS? To get the RHS, we just have to put the point in LHS. So, that will give us x1 square minus y1 square. So, this becomes the equation of normal at a point. What about normal in parametric form? Of course, same thing. So just exchange these two. So it becomes xt square minus y is equal to get the RHS we have to substitute the point here. Point is Ct and c by t. So it is going to give us c into t cube minus 1 by t. Okay. So this way we can get the equation of normal also. Okay. So normal at a point and parametric form of normal, both we have done here. Now similarly you can also derive slope form and you can derive condition for normal, but these are not required for rectangular hyperbola. The moment we mention rectangular hyperbola, the itself is borderline concept, so we don't go much deeper into this. Now if you get any questions on rectangular hyperbola, you can start with normal at a point and parametric form and then try to analyze. Now to get the normals through any point, we can also take help of this parametric form. So if I just put the point here and solve for t, so I will get 4 values of t. Based on the values of t, we can design the normal also. Okay. So in case if you get any question based on normals through any point, you can take help of parametric form and solve it. In fact, these two forms are sufficient to handle normals of rectangular hyperbola and don't get into the other forms. Okay. So in general, if we look at any institute or any book, rectangular hyperbola is not dealt with such depth, but here we are actually dealing with depth, so that much itself is already sufficient. Okay. So now let us move on to the chords. So these are the concepts of chords. One is chord of contact, you know the concept, it is going to be S1 equal to 0. Chord through a midpoint, S1 equal to S11. Chord joining any 2 points, S1 plus S2 equal to S12. And parametric form, you just have to take 2 points and derive it on your own. Okay. So now you don't have to even by heart this, you can remember the way of deriving it and then you can use it for problem solving. Today also I will take 1 or 2 examples on this idea also. Okay. So that means here we just need 2 points, Ct1 comma c by t1 1 point and Ct2 comma c by t2 another point. Now when we find the equation of chord, how do we do that? We can just apply 2 point form and derive it. Okay. So here y minus c by t1 by x minus ct1 is equal to c by t2 minus c by t1 divided by ct2 minus ct1. Now here we can cancel out c, and if we check, it becomes minus 1 by t1 t2 in the RHS. Now if we simplify this, what are we going to get? We will get y into t1 t2 minus c t2 is equal to minus x plus ct1. I can take x to LHS and ct2 to RHS. So I will get x plus y t1 t2 is equal to c into t1 plus t2. This becomes our equation of chord. But there is a simple method of remembering this chord. For example, if we check the tangent, tangent is x plus yt square equal to 2ct. This is what we have derived earlier. Now, how do we get the normal? We have already learned this. Just swap these two, swap the coefficients and reverse the sign. So it becomes xt square minus y is equal to RHS can be derived by substituting the point. So c into t cube minus 1 by t. This we have already done. Now let me explain the chord here. Chord can be derived like this. Now whenever we are using this parameter t square and t, for these two terms, for t square and t, write the expression of S11. Okay. So if it is degree 2, write S11. If it is degree 1, write S1. Okay. But you have to use both T1 and T2 because you are using 2 points here. Okay, so whenever there is degree 2, use GM, whenever there is degree 1, use AM. AM of T1 and T2 and here GM of T1 and T2. So basically it will come out to be x plus y into T1 T2, that means I have used the GM here, and here 2C into, for T I have to use AM, arithmetic mean, so which will give me this term. So this way you can remember both chord and normal from the tangent. Okay. So this is how I remember forms of rectangular hyperbola. Okay. So basically here we have understood how to derive the parametric form and also how to remember it. Okay. So these are only the concepts of chords. Out of these, which is the one that you need to remember? It is only this parametric form you need to remember. Rest all are standard formulae. So you just have to learn this and you have to use it. Okay. So with this we will close all concepts of chords, all concepts of rectangular hyperbola also. Okay. So now can we look at some problems? Okay. So before I go to problem solving, there is also one more important thing I want to mention. Okay. So if you want, you just make a note of this. Okay. So this is one home exercise for you. Okay. This is one home exercise. So what you are going to do is this, you take a chart. Okay. So this is just an idea. Okay. With this idea, I tried to remember everything in coordinate geometry. I did it in my 11th and 12th standard. You can also do it. You can also remember entire coordinate geometry. So what is the job? You take two charts, big charts of let's say A2 size or something. Take very big chart and in that chart put the entire data of coordinate geometry. Okay. So first one you will first do it and then you will copy the same thing in the second one and you stick one chart in your room on the wall so that your parents also will understand that you are studying, and the second chart you fold it and keep it in your bag. Whenever required you can quickly revise coordinate geometry. Now what is this chart and how to form this chart, how to make entries in this chart? For that I am giving you the idea. So here you are going to make a table in that chart. Okay, you are going to make a table and here you are going to get all curves. Okay. So let us say we have circle and then we have parabola, ellipse, hyperbola and if possible rectangular hyperbola also. Okay. If possible. Now what are the forms that you need to enter here? So here comes the list and this list may go on, it may be very huge list. That is why we have taken one big chart. Okay. Suppose let us say we go for standard form here. Okay. So what is the standard form for circle, what is the standard form for parabola, ellipse, hyperbola, everything you will write here. Okay. And also next, what are the other concepts of circles or any curves? What are the things that you have learned? Notation you already know. Notation is common for everything. So what are the concepts? First we understand the standard equation and then we understand the setup, which are also called as the characteristics. So you can write, you can make one column or let us say 2-3 columns for setup. So out of this foci can be one, directrices can be one row. Okay. And also vertices. And next, location of a point with respect to the curve. If you observe, for point to be inside the curve, for all curves it is S11 less than 0 except the hyperbola. So here it will become greater than 0. Now if you observe this pattern, you will remember it forever. Okay. So the main idea of making this chart is to make sure that you observe the pattern. Now after this you can go for all concepts of tangents. So in tangents we have many concepts. Let's say there is condition for tangency. What is the condition for circle? C square is equal to a square into 1 plus m square. What about parabola? A by m, c equal to a by m. For ellipse, a square m square plus b square. For hyperbola, a square m square minus b square. You see that it is all same. In ellipse, if I put a equal to b, I will get circle. And in ellipse, if I put b square equal to minus b square, I will get the hyperbola. So you can try to relate all of them. When you try to connect all of them, you will remember all of them. Okay. Now similarly, what is the equation of slope form? What is the equation of parametric form? What are the equations of normals? What are the equations of chords? What is the equation of diameter? So everything you can make a chart and you can try to remember. Now as our elders keep saying, if you write once, you will remember it 10 times. That is as good as reading it 10 times. So if you make this chart on your own, you will remember all forms together. And also when you are searching for this formula and writing, you are also actually revising the other chapters also starting from circles. So this way you will make the complete chart, and again you will make another chart just to make sure that you remember all of them. But when you are making the second chart, you are supposed to close all books and try to do it only by your memory. So this way you will try to remember. Now in future, if you want to revise, you can just look at that chart and your coordinate geometry can be revised within 5 minutes. Okay. So this is a technique that I use to revise the entire coordinate geometry in 5 minutes. Okay. So this I want you to try at home so that you will remember all of them. Okay. Come on, make a note of this. Okay. Now let us go to problem solving. Okay. So here there is one question. The orthocenter of triangle inscribed in a rectangular hyperbola lies on. Okay. In fact, this is actually a property of rectangular hyperbola. So if I take any 3 points on rectangular hyperbola, and if I take the orthocenter of that triangle, that orthocenter must lie on the same rectangular hyperbola. So how do we prove this? So to prove this, I will take 3 points in parametric form. I will show you how to do that. Suppose let us say I have taken one triangle here. Okay. So this is one schematic diagram. Okay. So this is A, this is B, this is C, and I will take A as CT1 comma C by T1, B as CT2 comma C by T2, and C as CT3 comma C by T3. Okay. And earlier we have derived the slope of the chord of rectangular hyperbola in parametric form, that was minus 1 by T1 T2. So that means slope of this line is going to be minus 1 by T1 T2, slope of this line is going to be minus 1 by T2 T3, slope of this line is going to be minus 1 by T3 T1. Okay. And also we are interested in finding the orthocenter. Now what is the best way to find the orthocenter? To find orthocenter, what we do is we calculate two altitudes and solve them. So for example, let us say if I want to calculate one altitude here, what is the idea? Altitude must pass through the point C and it must be perpendicular to AB. So I am taking this altitude as, let us say, alt1. Okay. So what would be the equation of alt1? It has to pass through C. So that means y minus C by T3 by x minus C by C T3 is equal to slope of AB is minus 1 by T1 T2. So slope of this altitude will be T1 T2 because M1 M2 must be minus 1. So this slope must be equal to T1 T2. Now when I simplify this, what do I get? I get y minus C by T3 is equal to x into T1 T2 minus C into T1, T2, T3. Now take all variables to one side and constants to the other side. So what do we get here? We get something like y minus x T1, T2 is equal to C by T3 minus C T1, T2, T3. This is the altitude passing through T3. Now by using the cyclic nature of these points, we can write the next altitude directly. So that is the beauty of these parametric forms, that is the beauty of the cyclic nature or cyclic symmetry. So here if I want the altitude passing through, let us say B, if I want this altitude, okay. So let us name this as altitude 2. It is passing through T2. So wherever I am seeing T3, just replace that with T2 and remaining exchange them cyclically. So what do I get? Y minus x into, here it is passing through T3, but here T3 is absent. So if it is passing through T2, T2 must be absent. So it must be T3 T1 is equal to, if it is passing through T3, T3 is coming in the denominator. So here T2 must come in the denominator. Similarly here all three are coming, so all three must come. So this way we can write the next altitude. So if you see, this is actually an easy method, but when we think about it that we have to calculate altitudes and solve them, it may look long, but it is not that long. It is actually very simple, okay. So now we just have to solve for x and y, okay. So if I subtract, y gets cancelled. So what will I be left with? X common and also T1 common, I will get T3 minus T2 here, and here if I take C common, I will get 1 by T3 minus 1 by T2, and this term gets cancelled. Now again if I further simplify, what do I get? I get x T1 into T3 minus T2 is equal to C into T2 minus T3 by T2 T3. So here T3 minus T2 gets cancelled and we will get x equal to minus C by T1 T2 T3. See, we already got x. Now similarly we can also get y. So if we just substitute it here anywhere, we will get y to be equal to minus C into T1 T2 T3, okay. So here if you observe, x into y is c square only, okay. X into y is c square only, which means the point lies on the rectangular hyperbola itself. Now if we look at this geometrically, so let us say we have one rectangular hyperbola here, okay. So if I take the triangle to be here, if I take triangle to be here, then the orthocenter will be on the other branch, okay. So here if you can form the altitudes, okay, and here also you can form the altitudes. So this will be our orthocenter, okay. Or if you take, let us say these 3 points, let us name them as A, B, C and this as D. So D is the orthocenter of triangle ABC. On the other hand, if I take the triangle ACD, for the triangle ACD, B becomes the orthocenter, okay. For the triangle ACD, B becomes the orthocenter. For the triangle ABC, D becomes the orthocenter, okay. So if you take all 3 points on the same curve, then the orthocenter will be on the other branch. If you take one point on the other branch, the orthocenter will move to the branch where 2 points are taken, okay. So this way we can understand the geometry also, okay. So with this we will close this question, okay. Come on, make a note of this. Okay. Can we move on? Okay, so next question. Consider a chord of this curve which is parallel to y equal to x line. It is given that chord is parallel to y equal to x line. The circle with this chord as diameter passes through two fixed points and find them. So, how do we do this? Let us first try to draw the diagram and get a method from the diagram. Okay. So, whenever we solve any question in coordinate geometry, what is our first step? To understand the question. So, here it must be parallel with y equal to x line. So, this is our y equal to x line. Y equal to x line is nothing but the transverse axis. Okay. So, suppose let us say if I take any point here C T1 comma C by T1, if I take any point here. Now, exactly here parallel to this line I need another point. Okay. Now, using symmetry we can generate the coordinates of this point. Okay. See, if you notice, this line is going to be y equal to minus x line, because our chord is parallel to y equal to x line. It must be perpendicular to y equal to minus x line, and this diagram, this hyperbola is already symmetric about this y equal to minus x line because it is the conjugate axis. So, that means what happens here? This equation is y equal to minus x. When we reflect any point about y equal to x line, what happens? X and y coordinates will exchange themselves, will interchange. That means x and y will get swapped. But here y equal to minus x, that means x and y must be swapped and minus sign also must be taken care. Okay. So, in this quadrant, in first quadrant, x and y coordinates both must be positive. So, here I am assuming that T1 must be greater than 0 because I have taken the point here, which means here if we observe, both x and y coordinates must be negative and x and y must get reversed. So, what do we get? Minus c by T1 comma minus c T1. That will be the coordinates of this point. Okay. So, here this comma is confusing. So, I will just write with some space, minus c by T1 comma minus c T1. So, here what I did is I swapped x and y and also I put minus sign. Okay. So, now we will find the equation of the chord. Okay. So, what will be the equation of chord here, or sorry, we are supposed to find the equation of circle having this as the diameter. So, let us apply the diametric form. Okay. So, equation of circle becomes x minus CT1 into x plus c by T1 plus, again for y also, y minus c by T1 into y plus CT1, this must be 0. Now, if I simplify this, what do I get? X square will come, y square also will come, and what will be the constant term? CT1 into c by T1, that will cancel out T1. So, that will be minus c square, here also minus c square. So, this is the constant term. So, first I collected all x square, y square terms and then the constant term. Now, I will collect all x terms. So, from here if I take x common, what do I get? If I take x common, I will get c by T1 minus CT1, and similarly from here if I take y common, I will get y into CT1 minus c by T1. This must be equal to 0. So, if I further simplify this, what do I get? X square plus y square minus 2c square plus, if I take c common and also this T1 minus 1 by T2, sorry 1 by T1. Okay. So I am taking this common, C also I took common, T1 minus 1 by T1 also I took common. So what is remaining? Y minus x is remaining. Now here if we observe, x and y are the natural variables and t is the parameter. So T1 is parameter, so that means 1 by T1 is also parameter. So if I take T1 minus 1 by T1 as my new parameter, which is the lambda, so then it looks like x square plus y square minus 2c square plus including c, we can take it as lambda, into y minus x equal to 0. So what is this giving us? It is giving us family of circles passing through the points of intersection of this circle and also this line. Okay. So that means we are getting infinite circles, but all circles are passing through those 2 points. So if we take it to the other page, we have one circle and we have one line, and this line is intersecting the circle at 2 points. So passing through these 2 points, we will get infinite circles. That is basically the family of circles that the equation is representing. Now that means these 2 points will become the fixed points, and if we want to calculate the fixed points, we have to solve circle and the line. So what is the equation of circle? It is x square plus y square equal to 2c square, and what is the equation of line? Y minus x equal to 0. So basically here we had s plus lambda L equal to 0. So L becomes y equal to x, s becomes this curve. Okay. So that's it. We can just get the points here. Okay. So if I put x equal to y, what do I get? X equal to 2x square equal to 2c square. So x equal to c comma c. Okay. So I'll directly write the point. Okay. Okay. So here the points can be written this way. So when I put x equal to c, y also must be c, y cannot be minus c, because y and x must carry the same sign. So c comma c is one point and minus c comma minus c is other point. Now let us look at the c. What is the c here? Okay. Okay, so c is directly c only, so there is no constant given, so we got the points. So this way we can solve the problem. So here if you notice, how did I solve this problem? I cracked 50% of the problem using the geometry, and remaining 50% I used algebra. Okay. So if you are alert, you can also take help of geometry to simplify your problem. Okay. Come on, make a note of this. Okay, next question. The sum of the slopes of normals from P to xy equal to c square is 4, it is given. Find the locus of P. So that means we need equation of normal here. We don't remember the equation. Let's assume that we don't remember. Then where do we start with? We start with the tangent, we go to the normal. Now we just remembered the tangent. What is the equation of tangent? X plus yt square is equal to 2ct. Even if you don't remember this, you can start from s1 equal to 0, it does not matter. Okay. So because here the question is about slopes, the problem must be solved using slopes. Okay. So we will convert this equation to normal and then that equation into the slopes. Okay. So this is our tangent. Now we are finding the normal. So it becomes xt square minus y is equal to c into t cube minus 1 by t. Now what is the slope of this curve? Slope is t square. So in place of t square I will put m. So normal in slope form becomes mx minus y is equal to c into m root m minus 1 by root m. Okay. Now this can be further written as y equal to mx minus c into m square minus 1 by root m. This is also fine. this is the equation of normal in slope form. See, I have just derived it from the basics and it did not take much time. Okay. Now, further we want this normal to pass through the locus point which is P. So, let the locus point be h comma k. So, that means the normal has to pass through this. See, this is here in this question we are using the concept of finding normals through any point. So, we put the point in slope form and solve for the slopes, because the question involves slopes, we are solving in slopes. If question was involving the points, let us say the question was to find sum of all ordinates or sum of all abscissa, then we may have to start with the parametric form of normal only. So, we choose our method based on the question. So, here I am choosing the slope form. So, what do I get? I just have to put it. So, I will just put it somewhere. So, m into h minus y is equal to c into m square minus 1 by m. This is what we got. Okay. So, now if I cross multiply, sorry, this must be root m. Okay. Now, before I cross multiply, because there is square root involved, what is the best way of getting rid of square root? We may have to square it. So, that means the degree will go up. Okay. So, let me just square it here. So, what do I get? M square h square, okay, this is k, my mistake, plus k square minus 2hkm into m is equal to, what do I get in RHS? C square into m square plus 1 minus 2m, sorry, m power 4 plus 1 minus 2m square. Now, I will collect all terms and convert this into a polynomial. So, what is our next step? To convert this into a polynomial equation. So, I will take everything to RHS, because RHS has the m power 4 term. So, c square into m power 4. Now, is there any m cube here? Of course, there is one m cube here. So, minus m cube into h square, and remaining terms are not required because there is only one term with m cube, and also we are interested in the sum of all slopes of normals becoming 0 or 4. Okay. We want sum of all slopes of normals to be 4. So, we are interested in only finding the sum of roots of this equation which is supposed to give us the slopes. So, I am not worried about the other terms. Okay. So, I am not worried about other terms at all. So, here if I take sum of all slopes, which is same as sum of all roots, it becomes minus of minus h square by c square, and it must be equal to 4, that is what is given. So, which means if I simplify this, what do I get? H square equal to 4c square, which means equation of locus is x square equal to 4c square. Now, what is the locus? Locus is pair of straight lines. One is x equal to 2c, other is x equal to minus 2c. Okay. So, this way we can solve the problem. So, here I have just shown as an example that even if you do not remember the forms, you can always derive them on your own and it does not take much time. Okay. Come on, make a note of this. Okay. Can we proceed now? Okay. So, next question. Find the locus of midpoint of the chords with length 2L. Length can be anything. So, just here we just named it as 2L. It can be any number also, it does not matter. So, because we are interested in length of the chord, so how do we start this with? We start with the points as CT1 C by T1, CT2 C by T2. Okay. So, if I take the points as A and B, A is CT1 comma C by T1 and B is CT2 comma C by T2. What will be the length of the chord? Length will be AB is equal to root of c square into t1 minus t2 whole square plus c square into 1 by t1 minus 1 by t2 whole square. Now when we simplify this, what do we get? We get one c outside and one t1 minus t2 here and divided by root of t1 square t2 square, which will come out to be t1 t2 only. Okay. Now this is given as 2L. So we will keep this aside and we will choose what to do with this at later stage after we get some equation for the chord and also in terms of the midpoint. Okay. So we are interested in finding the locus of midpoint. So if I take the midpoint as h comma k, so h must be equal to c into t1 plus t2 by 2 and y k which is the y coordinate must be equal to c into 1 by t1 plus 1 by t2 by 2, which is going to be c into t1 plus t2 by 2 t1 t2. Okay. Now from here we can get t1 and t2 directly or indirectly, however we want, but that is not required here. Our goal is to eliminate directly t1 and t2. Our goal is to eliminate t1 and t2 directly. Now to eliminate t1 and t2 directly, we can directly take the ratio or add them or subtract them, do something. Okay. Now before that, because this does not involve any equations of lines, we can straight away take the locus point as x comma y. So I can write x here, I can write y here. Okay. This will save some time. Okay. Now if I take the ratio, let us say if I take x by y, it is going to give me t1 t2. Okay. So in place of t1 t2 I can write x by y, but what about mod t1 minus t2? So that has to be dealt with separately. So mod of t1 minus t2 can be written as root of t1 plus t2 whole square minus 4 t1 t2. So because there is square root involved, in locus we do not want square roots. So that means you have to get rid of square root. So you have to go for t1 minus t2 square only. Okay. So it becomes t1 plus t2 whole square minus 4 t1 t2. Okay. Now let me derive everything using this idea. Okay. So that means here we may have to square it. So as I said earlier, we will decide what to do with this at later stage, and now we have decided. Okay. So let us just get this and substitute. Okay. So what should we get for t1 minus t2 whole square? We will be writing it as 4l square into t1 t2 whole square by c square, and also from here you can directly get t1 plus t2. So t1 plus t2 can be written as 2x by c. So we will use all of them here. So what do we get? This can be written as 4l square by c square into t1 t2 whole square, right? t1 t2 whole square, t1 t2 is x by y. So here we can write x by y whole square is equal to, what is t1 plus t2 whole square? t1 plus t2 is 2x by c. So we can write here 2x by c whole square minus 4 into, what is t1 t2? It is x by y. Okay. Now just simplify this, that will give you the required locus. So what is the locus? 4l square into x square is equal to, c square will get cancelled. So here we are getting 4x square and y square will come here, y square, and again the next term minus 4 into xy into c square. Okay. Okay. So this way we can solve this question. Okay. So here if you understand, the question is mainly about algebra. So, this does not have much geometry, it is purely algebra. Okay. So, sometimes it is also possible that some questions may come in coordinate which may involve pure algebra. Some questions may even jump into matrices determinants, some questions may jump into quadratic equations, some questions may jump into trigonometry also, some may jump into sequence series also. Okay. So, it is all possible. So, this way we can solve this problem. Okay. Can we solve one more problem? Okay. So, let us say there is this question. Okay. This is a little lengthy and but good question. Show that the locus represented by these two equations is a rectangular hyperbola. So, here t parameter is involved. So, how to get the idea of the curve? We cannot get the idea of the curve just by looking at the parametric form. We have to eliminate the parameter to see the nature of the curve. So, how do we eliminate here? X is given as a by 2 into t plus 1 by t, and y is given as, this is also a by 2 into t minus 1 by t. Okay. So, what is the best idea here to eliminate? Just think about it. If I square both terms, okay, let us say I do it like this, 2x by a whole square, it becomes t square plus 1 by t square plus 2t plus 2, okay, it becomes 2 into 1. Similarly, here 2y by a whole square, this will become t square plus 1 by t square minus 2. Now, by looking at this, we are getting the idea that we can subtract. Okay. So, in general you should get that idea just by looking at this, that if we square and subtract, all terms with t will get cancelled. That comes by experience if you practice more. So, now if I take the difference, so what am I getting? 4 into x square minus y square by a square is equal to, difference is coming out to be 4. So, 4 is getting cancelled. I am getting x square minus y square equal to a square. Of course, this is a rectangular hyperbola. So, we have just proved the first part. Now, what is the question? Show also that the equation to the normal at point t is this. So, how do we get equation of normal? Now that we got the equation, we can differentiate it and get the slope. Okay? Or we can also go for parametric form of tangent and then go for the normal also. Okay? So, suppose let us say I have taken parametric form of tangent, it becomes xx1 minus yy1 equal to a square. What about the normal? It becomes xy1 plus yx1 is equal to, we have to substitute the point here. If we put the point, it becomes 2 x1 y1. Now, just put the point here. So, what is the point? X into a by 2 into t minus 1 by t plus y into a by 2 into t plus 1 by t is equal to 2 into a square by 4 into t minus 1 by t, t plus 1 by t. Okay. We just have to simplify this. So, what do we get? 1 a by 2 is anyways getting cancelled. So, x divided by t plus 1 by t, this is what we got when we divided with this directly, plus y by t minus 1 by t, and equal to, these two terms are now in the denominator, 1 a by 2 will get cancelled and 1 2 also will get cancelled, equal to a. So, this is our equation of normal. Now, if we want to further convert it, of course, we can cross multiply here, take LCM and simplify it. Okay. So, this way we can solve this problem. Okay. So, here in rectangular hyperbola, what have you observed? You have observed that if you remember the idea of parametric form, if you remember the standard forms of tangents, chords and normals that we have studied from the circles itself, if you remember those forms involving S, S1, S11, you can solve all questions directly, either directly or indirectly using the standard forms. Okay. Sometimes some questions may involve significant degree of geometry. That means if you use geometry, you can solve them faster. Sometimes question may involve pure algebra, but if you practice well, you will gain that experience also. But keep your mind in alert mode, because in coordinate geometry you always see that cyclic nature and there is a pattern in algebra. If you crack the pattern, you can always solve the question. Okay. So try to make that chart that I have spoken about, and also at the end of every chapter, after you practice on your own, you have to make a list of 10 to 15 questions for quick revision in future also. Okay. So good luck with your practice. We will meet again in the next lecture with another chapter. Until then, have a great learning day. Learning shall never stop.